welcome to video 3. And so by now we've learned the power rule. So in our last video, we looked at integrating some functions like 5x to the fourth plus 3x squared plus 2x plus 5, for example. And the answer to this is going to be x to the 5 plus x cubed plus x squared plus 5x plus our constant of integration c. But there is a problem here. And it's that not everything in maths is a power of x. For example, our trigonometric functions. How would we integrate sine of x? Now, similarly, we've looked at these derivatives before, and adding one to the power makes no sense here. So today we're going to learn another category of integrals you simply just need to recognize. And so instead of asking, how do I integrate this? The real question to ask is what differentiates into this. And so what differentiates to give us sine of x? Well, we know that the derivative of cos x gives us minus sine of x, which is close, right? But not quite. So if we had a minus in front of the cos x, then the derivative will give us the positive sine x. And so we found what differentiates to it. So that gives us the answer to our integral, because this question is just asking what differentiates to this. And we've just found it, y equals minus cos x. And so the answer to the integral of sine of x is going to give us minus cosine of x plus our constant integration c. So the negative appears because cosine differentiates to negative sine. Don't memorize them randomly, always trace backwards. And so let's just write them out one by one. The integral of cosine x is going to give us sine of x. The integral of sine of x is going to give us minus cosine of x. The integral of minus cosine of x is going to give us minus sine of x. And so simply the integral of minus sine of x must give us cosine of x. You can see we're going down like this, looping back down. This is how this works. And so let's do another example. Let's do the integral of 4 sine of x. We discussed before how we can take the constant out here. And so this is the same as 4 lots of the integral of sine of x. And so the integral of sine of x we've just worked out is minus cosine of x. So we have 4 lots of minus cosine of x. And so our answer is going to be minus 4 cosine x plus some constant of integration c. So this is good. Now let's try the derivative of, the integral of, let's do 7 cosine x. Take the constant out, we're going to have 7 logs of the integral of cosine x. We've worked out the integral of cosine x is going to give us sine of x. And so the answer to this must be 7 sine of x plus c. We have some trigonometric facts that we should know about. And so the derivative of tangent x is going to give us sec squared x. So let's write that. The derivative of tangent x is sec squared x. So whenever you see the integral of sec squared x, we're simply asking, hey, what differentiates to give us sec squared x? And our answer is going to be tangent of x plus c. Towards the end of this video, I'm going to show you how you can work this out, not by simply just saying, what is its derivative? Because sometimes that doesn't always work. If I had some function sec squared x tan x over ln x, and I said, hey, what's the integral of this? You can't say, oh, I know a derivative for that, because most of the time you won't. These are standard integrals, so you should know the derivatives for them. But a lot of the time in maths, as you go on through the years, you're going to have to work it out yourself. And so I will show you actually how to arrive at sec squared x as tan x. We will actually look at how to integrate that. Next up, let's do the derivative of, sorry, I keep saying derivative of, let's do the integral of 2 sec squared x. This should become quite elementary now. Take the 2 out. What's the integral of sec squared x? We've just discussed it. We're going to get 2 tan x plus c. The next one you need to know about is the derivative of cotangent x. We have the derivative of cotangent x. The answer to this is going to be minus cosec squared x. And so we can ask, hey, what's the integral of minus cosec squared x? Well, it's going to be cotangent x plus c. Again, the plus c is going to be whatever that information was lost. Let's do the derivative of secant x. The derivative of this is going to be secant x tangent x. And so the integral of secant x tangent x is going to give us secant x plus c. Let's do one more. Let's do minus cosecant x. The derivative of minus cosecant x is cosecant x cotangent x. And so if I ask you to integrate cosecant x cotangent x, the answer is going to be minus cosec squared. Sorry, just regular minus cosec x. So we need to know that cos becomes sine, sec squared becomes tan, secant x tangent x becomes sec x, sine becomes minus cosec squared becomes minus cotangent, and cosecant cotangent becomes minus cotangent. The negatives aren't random, they come from derivative rules. Let's do a challenge question. Let's do the integral of 3 sine x plus 5 cos x. Break it up. The integral of 3 sine x plus the integral of 5 cos x. Pull the constants out. You're going to have 3 lots of the integral sine x plus 5 lots of the integral of cosine x. And so we know these integrals. That's going to be minus cos x. So we're going to have minus 3 cos x plus 5 lots of sine x. I said I would explain how to arrive at the integral of the function. And so this is just going to be now how we actually get there without just saying, I know it's something differentiates to this. Let's do the integral of secant x. So we've discussed that it's in the formula book, the answer to this, but we're going to do it by working it out. What is secant x? Well, it's 1 over cosine x. So what we really have is the integral of 1 over cosine x. And what can we do to this without doing much to it? We want to express it in another trigonometric form. So I'm going to multiply by 1. What does that do, Noah? That doesn't make much sense. I'm not really going to multiply by 1. It's a trick. I'm going to multiply by cosine over cosine because that's the same as 1. You understand? If I had this fraction here, cosine x over cosine x, it's just 1. And multiplying something by 1 doesn't change it, so we're allowed to do it. So this is the integral of 1 over cosine x times cosine x over cosine x. And it helps us to manipulate this function. What we have is cosine x now over cos squared x. And we want to integrate this. What is cos squared x? Well, we have an identity. Sine squared x plus cos squared x equals 1. And so 1 minus sine squared x must be cos squared x. So let's try writing that, see if that helps. We have cosine x over 1 minus sine squared x. And now we can do something called a u substitution, which we're going to look at in a later video. But this is simply just showing you how some of these arrive. And so all it means is when you've got a bunch of arms. And if you want to simplify it, we can let u equal something. In this case, we're going to pick sine x. What's the derivative of u? Cos x. We've learned that before. And so that's actually here. We're only out by this square, and that's u squared. So now our integral becomes du over 1 minus u squared. Now, algebraically, this is semantically equivalent to the integral of 1 over 1 minus u squared du. And so you could actually do partial fractions on this that you would have learned in A-level maths. I'm assuming the people that are watching this understand how to actually do this. And so we're going to do 1 over 2 lots of 1 plus u minus 1 over 2 lots of 1 minus u is our partial fraction now. And we're going to integrate this. And so we're going to get ln of 1 plus u over 1 minus u. And so that's the answer to this, but we're still in the u world. What is u? It's sine x. So we have ln of 1 plus sine x over 1 minus sine x. Now again, I kind of want to manipulate this by timesing through by 1. But we're going to pick the right power here. Let's do 1 plus sine x. So let's times this by 1 plus sine x over 1 plus sine x. Well, on the top, we're going to get 1 plus sine squared x, which is just cos x. And on the bottom, we're going to get 1 minus sine squared x. So that's going to be our cos squared x. And on the top, we're going to have 1 plus sine squared x. So we're actually just going to be left with 1 plus sine squared x over cos squared x. So we can break this fraction off as 1 over cos squared x plus sine squared x over cos squared x. Cos squared x. What is 1 over cos squared x? Well, it's going to be secant squared x. Sorry, secant x. We can reduce our powers. Ln of secant x plus, what is this? Tangent x. And so the answer to what is the integral of secant x is going to be ln of secant x tangent x plus c. And that's how you would integrate something like that. Hope you've enjoyed this video on trigonometric integrals. Today we learned the direct trig integrals. Next we'll look at some situations where trig functions become more complicated and need new techniques. And so I think the next part of this video is going to be on U substitution.